Hi, what a lovely day, isn't it? As a human being, we don't have any superpowers or magical powers to move an object without touching it. But physically, we can move it by force. We know that there are a lot of force that we know, such as gravitational force, normal force, and friction force. But what about van der Waals force? Are they the same force? Do students know about it? Although they learn it in school, but do they know it specifically? So let's find out.
What is van der Waals forces? Van der Waals forces include attraction and repulsions between atoms, molecules, and surfaces, as well as other intermolecular forces. They differ from covalent and ionic bonding in that they are caused by correlation in the fluctuating polarizations of nearby particles, a consequence of quantum dynamics. Being the weakest of the weak chemical forces, with a strength between 0.4 and 4 kJ per mole, they may still support an integral structural load when multitudes of such interactions are present. Such a force results from a transient shift in electron density. Specifically, as the electrons are in orbit of the protons and neutrons within an atom, of the electron density may tend to shift more greatly on a side. Thus, this generates a transient charge to which a nearby atom can be either attracted or repelled. Intermolecular forces have four major contributions. First, a repulsive component resulting from the Pauli exclusion principle that prevents the collapse of molecules. Second, attractive or repulsive electrostatic interactions between permanent charges. In the case of molecular ions, dipoles, in the case of molecules without inversion center, quadrupoles, all molecules with symmetry lower than cubic, and in general between permanent multipoles. The electrostatic interaction is sometimes called the Keesom interaction, or Keesom force after Wilhelm Henry Keesom. Third, induction, also known as polarization, which is the attractive interaction between a permanent multipole on one molecule with an induced multipole on another. This interaction is sometimes called Debye force after Peter J. W. Debye. Fourth, dispersion, usually named after Fritz London, which is the attractive interaction between any pair of molecules, including nonpolar atoms arising from the interactions of instantaneous multipoles. Returning to nomenclature, different texts refer to different things using the term van der Waals force. Some texts describe the van der Waals force as the totality of forces, including repulsion. Others mean all the attractive forces, and then sometimes distinguish van der Waals Keesom, van der Waals Debye, and van der Waals London.
All intermolecular or van der Waals forces are anisotropic, which means that they depend on the relative orientation of the molecules. The induction and dispersion interactions are always attractive, irrespective of orientation, but the electrostatic interaction change sign upon rotation of the molecules. That is, the electrostatic force can be attractive or repulsive, depending on the mutual orientation of the molecules. When molecules are in thermal motion, as they are in the gas and liquid phase, the electrostatic force is averaged out to a large extent because the molecule thermally rotate and thus prove both repulsive and attractive parts of the electrostatic force. The Lennard-Jones potential is often used as an approximate model for the isotropic part of a total repulsion plus attraction van der Waals force as a function of distance. Van der Waals forces are responsible for certain cases of pressure broadening, which is van der Waals broadening of spectral lines and the formation of van der Waals molecules. The London van der Waals forces are related to the Casimir effect for dielectric media, the former being the microscopic description of the latter bulk property. The first detailed calculations of this were done in 1955 by E. M. Lifshitz. A more general theory of van der Waals forces has also been developed. The main characteristics of van der Waals forces are: first, they are weaker than normal covalent and ionic bonds. Second, van der Waals forces are additive and cannot be saturated. Third, they have no directional characteristic. Fourth, they are all short-range forces and hence only interactions between the nearest particles need to be considered instead of all the particles. Van der Waals attraction is greater if the molecules are closer. And fifth, van der Waals forces are independent of temperature except dipole.
The first contribution to van der Waals forces is due to electrostatic interactions between charges in molecular ions, dipoles for polar molecules, quadrupoles or molecules with symmetry lower than cubic, and permanent multipoles. These forces originate from the attraction between permanent dipoles, dipolar molecules, and are temperature dependent. It is termed Kiesom interactions, named after Willem Hendrik Kiesom. Willem Hendrik Kiesom was a Dutch physicist who in 1926 invented a method to freeze liquid helium. He also developed the first mathematical description of dipole-dipole interactions in 1921. Thus, dipole-dipole interactions are also known as Kiesom interactions. These forces consist of attractive interactions between dipoles that are ensemble averaged over different rotational orientations of the dipoles. The energy of a Kiesom interactions depend on the inverse 6 power of the distance. Unlike the interaction energy of two specially fixed dipoles, which depends on the inverse third power of the distance.
The second contribution is the induction, also termed polarization or Debye force, arising from interactions between rotating permanent dipoles and from the polarizability of atoms and molecules. These induced dipoles occur when one molecule with a permanent dipole repels another molecule's electrons. A molecule with permanent dipole can induce a dipole in a similar neighboring molecule and cause mutual attraction. Debye forces cannot occur between atoms. The forces between induced and permanent dipoles are not as temperature dependent as Kiesom interactions because the induced dipole is free to shift and rotate around the nonpolar molecule. The Debye induction effects and Kiesom orientation effects are termed polar interactions. The induced dipole forces appear from the induction, which is the attractive interaction between a permanent multipole on one molecule with an induced multipole on another. This interaction is called the Debye force, named after Peter J.W. Debye. Peter Joseph William Debye was a Dutch-American physicist and physical chemist and Nobel laureate in chemistry.
The third and dominant contribution is the dispersion or London force that is found by Fitz-Wolfgang London. Such polarization can be induced either by a polar molecule or by the repulsion of negatively charged electron clouds in nonpolar molecules. Thus, London interactions are caused by random fluctuation of electron density in an electron cloud. An atom with a large number of electrons will have a greater associated London force than an atom with fewer electrons. Fitz-Wolfgang London was a Jewish German physicist and a professor at Duke University. His fundamental contribution to the theories of chemical bonding and of intermolecular forces are today considered classic and are discussed in standard textbooks of physical chemistry. With his brother, Heinz London, he made a significant contribution to understanding electromagnetic properties of superconductors.
So that is van der Waals force. We hope you can understand what it is all about. Thank you and have a great day. Bye bye.